Hello everyone, welcome back to my YouTube channel. Today I'm gonna solve this simply supported beam by conjugate beam method to find the deflection at D. This has a new idea. I hope it's useful for you. So I start by finding the reaction for these two supports and draw the moment diagram, then transfer this moment diagram into a distributed load to a conjugate beam. And how can I draw the conjugate beam? I already explained it, and I'll do it again, no problem. For this roller, it will be internal hinge, and this free and it will be fixed, and the positive sign moment diagram is going to be distributed load acting upward, and for this negative sign it's going to be acting downward. I'll find the resultant force for each distributed load on conjugate beam. These are not up to scale just because I want it to be more clearer. So for this curvature, the height is 5 and the base is 1.8. So the rule is to divide 2/3 times h times b, as I did in here. So it's going to be 6 over ei, the resultant force for this curvature. And the distance is half of b. And for this type of curvature, it's going to be 1/3 times h times b, as it's shown in here, divided by ei, and distance is the base divided by 4. And then finally, this one is easy, just a regular rectangle and triangle. We find the distances and the resultant forces. And then these, the whole concentrated loads, I'll transfer them into the conjugate beam itself by its distances, so I can determine the reactions at A dash and C dash for the moment and vertical forces. Finally, now I can determine the deflection at D dash, which makes the moment. So as we know, the deflection at D at a real beam will make the moment at D dash at conjugate beam. So the summation moment equals to 0, and this is going to be a negative sign. This distributed load is going to be negative sign, but for this vertical reaction, it's going to be a positive sign minus moment at D dash. I assumed it to be that way, no problem, you can assume it otherwise. And it's a negative sign because it seemed to be acting or the deflection is on the other side that I assumed. So that's all. It's very easy. Let me know down below if you have any note, if you have any question in your mind, and I'll be happy to help you. So thank you very much and goodbye.